This is Mrs. Zappia with Lesson 8, Sequencing Reflections and Translations, from Grade 8, Module 2. Student outcomes for this lesson. Students learn that the reflection is its own inverse transformation. Students understand that a sequence of a reflection followed by a translation is not necessarily equal to a translation followed by a reflection. Our essential question for this lesson: is a translation followed by a reflection equal to a reflection followed by a translation? Consider the picture below of a reflection across a vertical line L. In Lesson 7, there was an introduction to sequence of translations. It was clear that when a figure was translated along a vector, we could undo the move by translating along the same vector, but in the opposite direction, creating an inverse transformation. Well, not all transformations can be undone. For that reason, we'll investigate a sequence of reflections. Let there be a reflection across line L. What would undo this action? What is the inverse of this transformation? A reflection is always its own inverse. Consider this picture: a reflection across vertical line L. For point P, which is not on line L, what would be the reflection of point P be? So the reflection of point P is P prime. The reflection of P prime is a point reflected back across L, and we get back to P itself. So the reflection of point P is P itself. The same holds true for point A. The reflection of point A is here, and the reflection of the reflection is back over here at A. For point Q on the line, what would the reflection of Q be? It would be the same point. The lesson on reflection showed us that a point on the line of reflection is equal to itself. So the reflection of Q is Q, and the reflection of that reflection of point Q is Q. No matter how many times a point on the line of reflection is reflected, it will be equal to itself. Based on the last two statements, we can say that a reflection of a reflection for any point in the plane is itself. Let's write that out. The reflection of a reflection is the original point. We're going to go on to the next section, and we will be using this figure to answer some questions. What we've got here is a line of reflection, and we have figure A, and then we have the translation of figure A along this vector BA, and so that has moved it down. And then we also have this figure, which is the reflection of figure A across this line. And we also have a vector DC over here. And we're going to be answering some questions about this. So figure A was translated along vector BA. Describe a sequence of translations that would map the figure A back to its original position. So we'll take a piece of tracing paper and we'll translate figure A along vector BA. Since I'm going to be translating along this vector, I want to extend it a bit so that I can move it along the vector in a straight line. So I just extend that a bit. So I've got my original figure A, and I'm going to move it along the vector. And it ends up right here. Now the question is, what translation would I need to get it back to its original position. To get it back to its original position, I need to move it along a vector that's going to move it back in that direction. So I can use the vector BA, but I need to use this as this as my starting point and B as my end point. I'm going to draw it again so I have room on my transparency here. This is going to be my starting point, and this will be my end point. So this is vector AB. So I move this along vector AB, and I've got my figure back on the original. So let's go ahead and answer the first question. Figure A was translated along vector BA, resulting in translation A. Describe a sequence of translation would map figure A back to its original. So the first thing that we did is to translate figure A along vector BA. Then, to return it back to its original position, we translate the image of A along vector AB. Number 2. Figure A was reflected across line L, resulting in the reflection of figure A. Describe a sequence of reflections that would map figure A back to its original position. So here we have our original figure, and here's our reflection. Here is our line of reflection. And I'm going to reflect it over that line. And you can see this is where it ends up. So this is the reflection of A. The question is asking, what do I need to do now to return it to this position? In order to return it to this position, I can simply reflect it again over this line. And that returns it to its original position. So number 2, describe a sequence of reflections that would map figure A back to its original position. The first thing that we did was to reflect figure A across line L. The second thing is to reflect the image of A across line L. In other words, if you reflect the image and then you reflect it one more time, it is back in its original position. Number 3, can translation BA of figure A undo the transformation of translation DC of figure A? Why or why not? All right, so let's take a look at our picture. And we want the translation along vector AB, which moved the figure from here to here. Can it undo the transformation of translating along vector DC? And why not? Why or why not? So what do you think? Do you think that that will work? Here's our figure. And here is our vector. I'm going to go ahead and extend that vector so that when I translate it, it's going to be along a straight line. Alright, so I'm ready to translate it along segment DC or vector DC. So I move it along, and then question 3 was asking, can translation BA of figure A undo this? In other words, BA, so it would be going in this direction, will it undo moving it in this direction? Well, no, it won't. If you've moved it to the right, you need to move it to the left to move it back. And this would be moving it, of BA, would be moving it down. So the answer for number 3 is no. So let's go ahead and write that out. No. To undo a translation, you move the figure back to its original position. Using vector DC would not do that. In this next section, we want to know, does the order in which we sequence rigid motions, does it really matter? Consider a reflection followed by a translation. Would a figure be in the same final location if the translation was done first and then the reflection? So let's do both of those and see if it makes a difference. The first thing that we're going to do is the reflection of E, then we'll do a translation along vector AB. So here's vector AB. I'm going to go ahead and extend that a bit so that when I translate it, it is in a straight line. Then I'm going to trace the ellipse. And I'm going to do the reflection first. So I'm going to draw my line of reflection. And I'm going to reflect it across that line. So you need to line that back up. And draw the figure. So that is the reflection. Then the next thing it says to do is to translate it along vector AB. So here is vector AB. And I need to move my starting point to my end point. And trace my figure. Okay, so this is the translation. This is the reflection, and this is the translation after the reflection. Now, the whole point of this exercise is to find out if we do these in the reverse order, will it end up in the ending position? Okay, and this was the ending position. Alright, so let's take this one, and instead of doing the reflection first, we're going to do the translation first. So we'll translate along vector AB, then reflect across line L. So I'm going to go ahead and I'm going to darken my ellipse so that I can see it better here. And I'm going to translate along the vector, so I need to extend the vector. draw my vector. Then I'm going to move the starting point to the ending point. So this right here, this is my translation. So this is my translation. And then the second set of directions said to reflect it across line L. So here's my figure. Here is line L. And I need to flip it over, line it back up, and then here is my final figure, and that was the reflection. So this is the reflection after the translation. So this is our final position, and on the previous example, this was our final position. So notice that when you do the reflection and then the translation, we ended up lower than the line of reflection. And in this example, when we did the translation first and then the reflection, we ended up on the right side of the line of reflection. So the whole point of this exercise was to find out if you change the order of reflection, translation, or translation reflection, does that affect your final image? And the answer is yes. So here's what we know. We know that a translation followed by a reflection is not equal to a reflection followed by a translation. In other words, if you do the rigid motion in a different order, you get a different image. There's a video provided at this site that is a good example of a sequence of rigid motions, and it's only about 2 minutes long, so I would recommend that you would watch it. We are going to go ahead and read the directions for numbers 4 and 5, and then I would like you to pause the video and complete those problems. So let S be the black figure right here. And for number 4, let there be a translation along vector AB and a reflection across line L. Use a transparency to perform the following sequence. You're going to translate the figure S, then reflect the figure S, and label the image S prime. Then for number 5, you're going to reflect the figure first, and then you're going to translate it. So for number 4, you're going to translate, then reflect, and for number 5, you're going to reflect and then translate. And then we want to see, does the order of those sequence of transformations change where the image is located? Okay, so let's get started with number 4. I would recommend pausing the video and trying this on your own, and then following along. Okay, so the first thing we want to do is to extend our vector so that it ends up in a straight line. Then I want to draw my diagram. And this is figure S, and we are going to move it along vector AB. So this is our first transformation. We're translating it along the vector, and it ends up right here. Now our second step is to reflect over the line. So I'm going to draw my line. And I could draw this image right here if I wanted to, but I don't really need to. Okay, so I'm going to go ahead and reflect it over this line now. Line your tracing paper back up, and then I'm going to darken my image. And that was a sequence of transformations where I did a translation along vector AB, and then I reflected it across the line. So I'm going to go ahead and darken that a bit and then label it. And the direction said to label that S prime. And this is where I did a translation along vector AB, then a reflection across line L. Okay, so that's number 4. Number 5 said to reflect the image first and then translate it. Alright, let's see if I can still use this piece of paper. Okay, so first thing I'm going to do is reflect it across this line. So I've already got my line. I'm going to draw my figure, and this is the one that I'm flipping, so I want to make sure and trace the right one, or use the right one on the next step. So I'm going to go ahead and reflect it across the line, and so this is my reflection. Then the next thing is to translate it along the original vector AB here. So I'm going to darken that on my paper, and I'm going to move it along. This is translating along the vector, so I'm going to move the starting point to the end point. And my final figure ends up right here. I'm just going to darken that a bit. And the direction said to label that S double prime. So the sequence of transformations for this figure, the first thing that we did was to reflect across line L, then translate along vector AB. So in both of these sequences, we did a translation and we did a reflection, but we did them in the opposite order. In this figure, we translated first and then we reflected, and we ended up here. For the second sequence, we reflected first and then we translated, and our image ended up over here. And this again clearly shows that the order of the transformation affects where the image ends up. We are done with number 5 now, and we're ready to move on to number 6. Using your transparency, show that under a sequence of any two translations, translation and translation O, along different vectors, that the sequence of translation followed by translation O is equal to the sequence of the translation O followed by the translation. That is, draw a figure A. Alright, we can do that. And two vectors. Okay, let's just go ahead and do that. We want to draw a figure and two vectors. I think I'll just draw a rectangle. And it said to label it A. And two vectors. So I'm going to put a vector over here, and I'm going to call that vector AB. And for my second vector, I'm going to go in the opposite direction, and I'm going to call that vector CD. Show that the translation along the first vector, followed by a translation along the second vector, places the figure in the same location as when you perform the translation in the reverse order. So the first thing I want to do is extend my vectors in a straight line so that when I move my figure, it will move to the correct location. So I'm just going to extend both of those vectors a bit. Then I'm going to trace figure A and I'm going to translate it along vector AB. Alright, so that is the location. Now the next thing is to translate it along CD. Well, that barely fits on the tracing paper. That's alright, I can make it work. So here is CD right here. And now I need to move the figure along CD. And this is the final position of my figure. So I'm going to darken that and call that A prime. And this is the translation along AB, then CD. Then it said to do the translation in the opposite order and see if you end up in the same position. So I'm going to go back over here and I'm going to take the original figure and it's moving along CD first this time. Okay, so there's my new figure, and now I'm rather AB. So here I'm going to move my starting point to my ending point. And it ends up right here, which is where the A prime is. So we have proven that when you are translating and you're doing two translations, it doesn't matter what order you do them in. Now, draw two new vectors and translate them along just as before. This time, label the transformed image A double prime. Alright, so I just need two new vectors, and I'm going to make a vector, maybe over here, and I'm going to call that vector EF. And I need a second vector, and let's move it here, and I'm going to call that GH. And we want to repeat the process. So before I was moving, down and to the left and then to the right. And here I'm moving to the right and then to the right and up a bit. And we want to know, will it still hold true? So I'm going to go back. Let's see. Alright, here we go. So I'm going to start with my figure A. And I'm going to translate along the vector EF. Before I can do that, I need to extend it so that it is a straight line when I translate it. And I also need to do that with GH. Back to the original position, and I'm going to move my starting point to my ending point. Alright, so this is where my new figure is. And now I need to do my second translation, which is along GH. And I'm going to move my starting point to my ending point. And my figure ends up right up here. And they said to label that one A double prime. So this was in the order of translation along vector EF, then GH. And now I need to do it in the reverse order. So I'm going to go back to the original, and I'm going to move the image along vector GH. So my position is right here. Then I'm going to move it along vector EF. And my position is right here. And we have just shown that when you're doing a translation along a vector, if you're doing two of them, it doesn't matter what order they are in. Question 7. Does the same relationship you noticed in exercise 6 hold true when you replace one of the translations with a reflection? That is the following statement true? A translation followed by a reflection is equal to a reflection followed by a translation. Well, we proved in exercise 4 and 5 that a reflection, translation, order matters. So the answer is no. In exercise 4 and 5 showed reflection, translation, order matters. A reflection, then a translation. Puts the image in a different location. Than translation, then reflection. In Lesson 8, we learned that a reflection across a line followed by a reflection across the same line places all figures in the plane back to their original position. A reflection followed by a translation does not place a figure in the same location in the plane as a translation followed by a reflection. The order in which we perform a sequence of rigid motion matters.